so let's start. So in the last days, I have been preparing something to talk about TypeScript, and I decided to call this talk um, TypeScript Everything, because nowadays I use TypeScript on everything. There is nothing where I think it would be a bad choice. It doesn't, for me personally, it does not matter the size of the project. It could be like an enterprise project or a single line node script that does something silly. I just think there's no reason not to use TypeScript. So I'm gonna go through the things that TypeScript is and what it does, so you can, I guess, draw your own conclusions. Um, so first of all JavaScript is TypeScript. So you can get any JavaScript code, put in a TypeScript file, and it's gonna be valid. So TypeScript is not like CoffeeScript or um, what's the name? Uh, Rust? Not is it Rust? Or I think I have it written down here. But it's not like CoffeeScript that is a different syntax that generates JavaScript code for you. It's actually JavaScript code. And TypeScript follows the ECMA standards. So they are never going to create like some crazy syntax. They're gonna follow what is in the ECMA specification. Um, so by default, when you compile a TypeScript file, it transpiles into JavaScript and it has some knowledge that you can define in the target. So there are some available targets. You can, for example, compile some piece of code in ES3. Then it's going to generate all legacy code needed to run in ES3. Or you can specify like ES5 or 6, and the generated output is going to be different. TypeScript, they they don't have everything because of that in their transpiler, because they only take things from stage 3. So stages, they work like yeah, there's a document here explaining, and basically stage 3 is candidate. It means it's almost ready to be released and become a new thing in JavaScript. But before it even finishes being a thing for JavaScript, you can already use that in TypeScript. So basically it looks like this. With TypeScript, you can execute the JavaScript next, which is going to be the next things coming to JavaScript. And you have everything that JavaScript today has. So basically you have more things, and you don't have to worry about things. Um, and I just found out when I was writing this blog post that optional chaining is in stage 4. That means it is already supported by TypeScript. So you can actually open VS Code. You can type the question mark after a variable, and that's going to generate the code for you. So you can already do that today. It's already supported. I have the example right here. Maybe you can zoom. So on the left side, I have my TypeScript code, and on the right side, I have the generate output for this code. So for example, if I delete this code over here, and I call the TypeScript compiler to compile this file, um, I messed around with the configurations here, or maybe I just need to close this file. Okay. Oh, I changed the script, I think. Oh, okay. I can't do that right now. I'm sorry. Uh, it's because I have something special, which I'm gonna talk here. So actually, there's a new thing in TypeScript that you can combine it with Bubble. And it means you can use things in stage 0. You can use things in any stage. You can use anything. So it works with anything. It's no longer just stage 3. You can use things from a straw person. And they have an example here how to configure the project to do that. And they even have an example file there. You basically build in 2 steps. So you first, with TypeScript, you have to build types, which is this command emits declaration only. And this is going to compile only the types for you. And then you can use Babel to compile the rest of TypeScript, and it's going to generate the actual code using whatever presets and plugins that you decide to use here. So you can use anything that exists, or you could even create your own. So it's not this powerful. You can do literally anything now. TypeScript is very mature. It has been around since 2012, which means 8 years, about 8 years. And most of the mainstream packages on NPM already have some support for TypeScript. So I actually watched a video where Anders Helsberg was talking about that if they look at the packages that depend on TypeScript, um, the about 1% has TypeScript types, and from this 1%, all dependencies have 70%. 70% use TypeScript. It means that the packages that everyone uses have TypeScript. So, for example, Chalk, the package to put to console log with colors, that has types built in. So there are 2 ways you can get types in your favorite packages. One of them is when developers bundle the types in the package, so you can just install the package and you have the types. So that's the case with Chalk. I can show here how it looks like. So when I install the package Chalk, I can see the files inside, and one of the files is a .d.ts. Thanks, Daniel, for the follow. So one of the files is the definitions file. Thanks, Will, for the follow. So this file .d.ts is an extension for the types. It's whatever it builds the types. So we have here all the definitions for the Chalk package. So if I try to use it, so if I try to import something from Chalk, it gives me a list of everything that it has because it knows all the types and all the objects that it has. So I can just import green or blue, and then I can just use, and it tells me how to use it. So blue is a function, and I can pass some text. So and because it's typed, it knows the types. It doesn't allow me to do something wrong, like passing. Well, in this case, it takes anything, but we're gonna see in the following examples. Thanks, Eduardo, for the follow. Yeah, so let's see. One Thanks, Chud, for the follow. Nice name. Okay, let's go in step by step. So you saw that types can be bundled in a package, and the other way you can have types is in this Git repository called definitely typed. So it's a repository that was born just a few weeks after TypeScript was born, and it's highly supported by the community. So if you want to use packages for, if you want to use a package, for example, Shopify, and they don't provide TypeScript definitions for you, you're surely going to find someone that wrote the definitions in this repository. This repository has over uh, a lot. Over it has thousands of definitions, literally. Here, it has 5,888 folders, and inside each folder they have a lot of definitions. So you can find types for everything here. Thanks, Glauber, for the follow. Uh, yeah, so you can find types for anything. And the way, so let's see, how do you get those types? So there are two ways to get types. One, so if the types are bundled in a package like Chalk, you can just install the package and you already get the types automatically. If the types are not in a package, the way you get the types is you install a package, add types, slash, and the package name. So for example, I can install types for Node by doing add types slash Node. I think you can do for Express. I don't remember if Express is built in or you have to install, but it's available to install from here. Thanks, Ed, for the follow. So you can install types like this, or moment, for example, as well. You can get types for moment. I think Lodash types are built in. I'm not sure. But so there are two ways to get types. It's either bundled or you just have to install add types slash the package name. Yeah. And if you are using Visual Studio Code, you are already using JavaScript and you don't even know. You might not even know. So I can show this. Thanks, Consolo, for the follow. So if you are on VS Code and you have a JavaScript file, if you do window dot, you get auto completion. So you can see here everything that a window has. For example, alert or the code URI component. And that's because, thanks Carlos for the follow. That's because you have these types inside VS Code. So VS Code has TypeScript installed into it, and it can help you providing types even for JavaScript. Thanks Flash, thanks Wesley for the follow. Thanks Mari for the follow. Yes, thanks, thanks Fabio for the follow. Thanks for all the follows, guys. Yeah, so TypeScript is inside VS Code, and it can help you even if you are coding in JavaScript. You can even I forgot what I was going to say because of the follows. But yeah, in short, you have TypeScript already, and you might not even know, but you are using if you are using VS Code. Okay. Thanks, Katie, for the follow. Yeah, so here is something I talked about earlier, but I'm going to go over it again. So is TypeScript like CoffeeScript or Dart? No, absolutely not, because TypeScript follows the ECMAScript syntax, the standard. So they're never going to create a new syntax sugar. They're gonna follow the specs, implementing things on stage 3, which is a candidate to be released into JavaScript, and they're never gonna go astray. They're never going to have a syntax like CoffeeScript or Dart has. That's not the goal. Um, so there is this image here. Um, and I guess I will talk about this a little later. But you have to have in mind that all JavaScript is TypeScript. There's nothing in JavaScript that you can't do in TypeScript. You can do everything that JavaScript does. If you're doing something wrong, you can do something wrong in TypeScript if you want to. That's the difference. TypeScript allows you to do anything. So there's also the concern about the learning curve. So basically, I think, in my opinion, there are only two things you need to get started. So I guess it even depends. So if you are starting a new project from scratch alone in TypeScript and you don't know TypeScript, I guess you need to know two things. You need thanks Melanie for the follow. Um, you need to know thanks Felipe for the follow. Um, so if you're starting a new project from scratch in TypeScript and you don't know TypeScript, you need to know how to create the configuration file, because that's the main thing. And you need to know how to do some basic types. And that is really simple to learn. So basically, I guess I'm just going to create a new project because I made a mess here. Thanks, Buckner Life, for the follow. Let's just switch folder because I have too many things here I was playing with. So you need to thanks Guilherme for the follow. So if you want to play around and create a project from scratch with TypeScript, first thing you need is to install TypeScript. So I just created an empty package and I'm installing TypeScript into it. And then the next thing you need is to create a configuration file. So the compiler, the executable that TypeScript has is called TSC. And TSC is, you can see it inside node modules. Inside the .bin folder, you can see TSC over here. And that's the compiler. That's what you call in a file to transform it from TypeScript to JavaScript. npx is basically something from npm that allows, from npm that allows you to execute things in bin or even remotely. In this case, it's going to be executing this file over here. So if I call the compiler passing the option init, it's going to create the configuration file for me. So here I have the configuration file, and it has a lot of comments. So if you're new, you can understand what things do. By default, it starts being restrict and has some options here. So usually what I like to do is to delete everything and only keep the two main things. The essentials are the target and the module resolution, which I think it defaults to CommonJS, but just in case, let's leave it like this. So now I have a configuration file, and if I want to start coding in TypeScript, I can do something like this. Sorry, I can't type. Okay. Yeah, so far here, I don't have any types. I guess let's do it a little bit differently. So here I have a function, and I'm using JavaScript basically. I don't have anything that is TypeScript specific here, and it works just fine. But if you notice, I can assign food to a variable, and now my variable is going to be of the type string, because TypeScript can infer types. So it knows that if this function returns a string, it knows that this variable can only be a string. But that's not something you need to know. I just wanted to show this. But what you need to know is how to add types to things. So let's say I have a parameter bar. The syntax to add types is colon and the type name. For example, bar string. And so that's all you need to know. You need to create the configuration file and know how to type things. And you don't always need to type things because it can also infer types. So, and you have to know the list of the basic types. So one of the most important types is the type any, which allows the variable to be anything. So you basically go back to JavaScript and you can do anything with the variable. If you have any problems with types and you need a quick workaround, you can just cast the variable to any and then do whatever you want. That's not really recommended, but that's possible. You have the type string. For any sort of number, the type is called number. And for booleans, it's called boolean. And then I think that's it. So basically the syntax is column and the type name. So here I give a more robust example, targeting ES6 and applying this lib. And then I explain that the type is column and the type. And that's all you need to know the very basic of TypeScript. And it already helps you. Just knowing that, it's already a lot that you can gain with it. So TypeScript has an official website called typescriptlang.org. And under documentation, they have this handbook. And this handbook explains everything that you can do with TypeScript. And the very first thing is basic types. So it explains how you do strings, arrays, and other things. One thing that I remembered just now is that on Guilherme's talk about GraphQL, he was showing that we could have a type. Let me open GraphQL. So we could have a type like string, and it would look like this, right? And then if you want an array of strings, you do like this. Am I right? But basically, my point is that it's similar to TypeScript, but TypeScript is slightly different here because an array of strings is first the string is lowercase and the array goes after. But it's very similar to GraphQL in a sense. Oh, it is a string array. So okay, then I guess what changes is it's lowercase for TypeScript. Cool. Yeah. So some of the benefits, you can catch errors before even running your app. So do you see the code here? They look exactly the same. They are actually exactly the same. And there are no errors going on here. Does anyone know what the error here is? I guess not. Right? I either no one wants to answer or no one knows. I'm not sure. But the point is, you might have spent already some seconds trying to figure out what's wrong. And with TypeScript, you can see in less than a second what's wrong. Yeah, so people don't know, I guess. Okay, so let's go this then. So let's see. I have a function compare, which takes name true. It returns name dot local compare name true, and then it calls compare, passing some name here. Okay. Okay, so here's the function. Carlos got it. Carlos knows the answer. But the point is, you don't see any errors here. And you might miss this because there's a typo here. There's no function called local compare. It's called locale compare. So with TypeScript, if I add types to this, then it knows that in the type string, we don't have local compare. So it says this property doesn't exist on type string. So you can go here and autocomplete, and then you can find the method you're looking for, which is locale compare. So with TypeScript, I took less than 1 second to find the error, and without it, I would have to look for typos, and I might miss something. You know, when sometimes you copy a string, go somewhere else, and then you paste, and then you go back and paste again, and then you compare, and then it's the same. What's wrong? So you avoid that. That's never going to happen if you have types and you let the compiler figure out what's wrong for you. So that saves a lot of time. Yeah. So here I showed one example uh, on the type string, but you can also type your stuff. So when you use your own stuff, you can catch errors there. So for our own stuff is if I try to pass a number instead of a string, I can see the error here already. And if I don't have this type, then I don't see any errors. I have to read the code, understand what it's doing to find the error. So in short, it takes longer for you to figure out what the errors are. Um, okay. Yeah, here I guess I just have a variation of the example I just showed, where I am trying to pass a string to a function that takes a function as a parameter, and then it doesn't allow me to. It's just a variation of passing a number to a string here. So TypeScript tells you that there's something wrong, and with JavaScript you have to figure out by yourself. Um, yeah, and if you try to run this code, even though like, um, yeah, if you try to run this in the console on the browser, you're gonna see an error, and this error doesn't tell you where the error is actually. So if you look here, it says uncaught, uncaught reference error. Kappa is not defined. And if you look for kappa, there's no variable called kappa. So there's a string kappa. Um, so for people that don't know what kappa is, it's a Twitch emote, a very popular one. If you type kappa in chat, you can see it. I can explain later. Anyway, um, yeah, so with JavaScript, you only see the error after you run it. Before you run it, you don't see anything. With TypeScript, you saw immediately that there is something wrong here. Kappa. So, and this is something I touched before, but I'm gonna go through again. So you can TypeScript. It has the types can be inferred from usage, or you can explicitly tell it what the type is. So for example, if I do a const name equals something, um, let's do foo. Then I know that foo is a string. I can see that foo is a string and gives me autocompletion for anything that a string has. And that's because it understands that the left side of this operation is receiving a string. And so that's implicit. And to make it explicit, I can say that the type is a string. I do find this very redundant because you're saying that a string is a string in a way. But one case where this can be useful is if you have a string and you don't immediately assign a value, and only later you do that. So if you try to assign something different from a string, you get an error. Yeah. And TypeScript also supports multiple types. So I can say that foo can be either a string or a number. And now this line is acceptable because I'm saying that it can be both. Um, and if you want to use a string method, for example, foo.localeCompare, it doesn't allow you to because it understands that the type could be a number. So the way you do this is you check for the type in runtime. So you need to dynamically check the type of foo. If it's a string, then I can do whatever with a string. So inside this scope, it knows that my type can only be a string. It's never going to be a number because I'm checking it dynamically over here. So that's how you can handle different parameters. This is very common in some packages that have the one I can remember right now is jQuery, that you can pass parameters in a lot of different ways here. You can have a function, you can have an object. It accepts many different uh, types of parameters. So you can say it's any type, and then depending on the type, you do a certain thing. Yeah, so what I showed just now is called type flow. So it understands what my types are. Sorry. It understands what my types are in runtime. Uh, Not exactly in runtime, but uh, because of my dynamic checks, it understands what my types are inside certain scopes. So here I have a more complex example. Nice, Fluffy. um, okay, so into this example, I have all sorts of kappas, which you can see in Twitch chat, and I have a variable that can be any of these types. So I'm checking in runtime. In runtime, if the emote is an instance of kappa. So inside this scope, my emote is absolutely going to be of type kappa. Kipo. Yeah. Um, kappa kipo. So here it's gonna be a kappa, and then in the second if, it can either be a kipo or a kappa ross. So here it can be two types at the same time. In the third if, I'm checking if emote is not an instance of kappa clause. So it means that in here, my kappa is going to be kappa pride, the type of. And if it's anything else, the process exits. So this is one example that I adapted from a talk from Anders Hausberg, where he made the same example but with different names. And then he made a question at the end. What is the type after all the ifs are done? So in this last console log, what would be the type of emote once it reaches the end? Does anyone know? So you can see what's happening in the messages here. In the first console log, it's going to be kappa. In the second, it can be either kipo or ross. In the third, it can be kappa pride. And then after everything, what can it be? So we might be taking some time to guess, but TypeScript can guess. That's badly formulated. Okay, let me write this down then. So if I have many classes, I guess in Anders' talk he showed the code, so I guess that made it easier to understand. So I have 5 different classes. My emote can be any of these types. Right? So if I say emote instance instance of kappa, and I put my mouse over emote, I see that emote can only be of type kappa. If I do else if emote instance of kipo or emote instance of kappa ross, and I put my mouse over it, it can be either the type kipo or kappa ross. And then the last one, else if emote is not an instance of kappa clause. Then my emote type is kappa prime. Oh, I typed prime, not pride. Oh, so I made a mistake. How am I gonna fix this? So, because TypeScript knows the types and it knows all the references. If I have a comment here, if I say kappa prime is not a thing, and I select this string and select all occurrences of this string and rename, it's going to rename this comment, but I don't want to rename this comment. I only want to rename my variable. So because TypeScript knows the types and it knows all the references, even across files, so I can press F2, or I guess I can do rename symbol, and I can type my new thing, kappa pride. And it renames only the references to the variable. It does not rename comments or things that are not the same reference. Okay, anyway, so going back to this example, the other condition is that the process is going to exit. And my question was, what is type of emote after everything? So let's go. So if emote is type kappa, it goes here. So it can be the type kappa. Am I doing this right? Okay. So it exits if the type is kappa pride. Okay, so you see, it's kind of hard to figure out, but TypeScript just tells you. So, okay, so this type can be kappa, kipo, kappa ros, or kappa pride. It cannot be kappa clause, because if it's kappa clause, it exits the application. So it's never going to be kappa clause when it reaches this point in the code. And you can easily see because TypeScript tells you. You don't have to figure out. Yeah, the emote can be set to anything because if it's kappa clause, it's going to exit. So this line is never going to be reached. So it cannot be this type because it's never going to reach here. So it can be all other types that doesn't exit the process. I'm just gonna move on. If you have any questions later, I can answer. So in this blog post, I also have some links. So if you want to see the Anders Helsberg example, you can check it out over here. Maybe he explains a little better than I do. Yeah, so these are some things I already talked about, that you have statement completion. So if you do a new date, you get all the parameters that a date takes. So it takes a value, and here you see multiple types. So you can pass a string, a number, or another date. And it even has overloads. So you can just pass different parameters, or even no parameters. So that's also possible with TypeScript. Uh, the packages. So earlier I showed chalk. I was importing green, and green gives me all the type information, all the parameters that it takes. And VS Code also supports JSDoc, so it can show you JSDoc information as well, along with the type information. So why type? So you want to type because of everything that I said so far, and because there is actually a study that shows that typed languages can prevent 15% of bugs. There's even there is a PDF file with the full study here. But if it's easier to read, I found also a blog post that boils down it a little bit, and then it shows everything that the document shows, but in a different language, maybe a little bit easier to understand. And basically, they found out that having types can prevent 15% of bugs. And they did this study checking out big GitHub repositories all over the place. TypeScript was initially meant to be for large-scale applications. I watched so Microsoft has this build event where they talk about their technologies. So they talk about C#, TypeScript, and a lot of things. And Anders Helsberg was talking about large-scale applications. I thought it would be higher than 15%. Maybe. Well, so this study was conducted on big GitHub repositories. Not so like it. So this study was for that scenario. Maybe in other scenarios the number could be higher. But I don't have any empirical data on that. The only data I have is this one. Yeah, so back in 2016, during this build event, Anders said something that really caught my attention, which was very large JavaScript code bases tend to become read-only. When you get to a couple thousand of lines of your code, sorry, let me start over. Okay. Very large JavaScript code bases tend to become read-only. When you get to a couple thousand lines of code, you dare not touch anything in there. So basically, he was saying, he even said that at some point, your code gets so big that your code becomes read-only. You can't change anything because your code is so big, it has so many references that you don't know the impact of changing anything. Reading that, I'm having flashbacks. I'm so glad we have TypeScript today. You have no idea. Yeah. So, and he is always talking about um, the only way to handle large JavaScript code bases is through optimized tests. Yes. If okay, so I guess because you said that, I'm gonna say something. There is an argument that some people make. I don't know why, but they say that TypeScript is bad because you don't do unit tests. So they completely miss the point. TypeScript is not meant to replace unit tests. Yeah, period. So even if you use TypeScript, you should write tests the same way you write for JavaScript. But yeah, your point, I guess, was not that. Your point was that with JavaScript you have to have tests, otherwise you can't test anything. Otherwise, you would have 15% more bugs. Yeah, and yeah, exactly. Okay, so Anders talks all the time about how TypeScript provides a lot of tooling, so you can easily refactor references across files. You can get auto statement completion. You can do a lot of things with TypeScript. And it just helps you develop, and you don't have to worry about type things correctly, not making typos. only finding errors during runtime. So you don't worry about that anymore. Um, yeah, so here I have one example of the rename feature that I just showed, but like I have some comments. I have three different functions, some comments, and the same variable in some of them. Like, so here, for example, in the first function, I have the word copy. In the function name, I have the word copy in the parameters, and I have the word copy inside the body of the function. I also have the word copy in another comment of another function, which is called copy, and I can rename just this variable and just what references it. So I can rename just this parameter and the variable inside this scope. So TypeScript allows you to do that. Without TypeScript, you'd have to select words, and you could maybe select a comment in between functions or select a function name in between. And you would also have to manually go to other files to rename in other files. With TypeScript, it does everything for you, and it knows all the references to that variable, so you don't have to do anything. Just rename whatever you want. So code is no longer read-only. And after the rename, you can see that only this and this changed. Yeah, and I found a tweet that some tooling that TypeScript can do. So here they have a sort of reduction code with lots of nested fors and lots of variables, and they're gonna show. Um, I don't know the quality of this on stream. I hope it's good, but they will be refactoring this, extracting functions. So you just saw that they selected this piece of code and just extracted that to a new function. So now there is a new function with all of that, and they keep refactoring it very easily. So they are breaking a function that has a cyclomatic complexity of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Uh, over 15, I guess, the complexity of this function would be. And they are refactoring just by selecting extract a new function. And now the complexity starts to get reduced to the point where it's in a single responsibility principle. So at the end, they have something like very small as possible functions. Yeah, it's basically this code is not very good, but they just wanted to show that you can refactor a really messy function easily by just exporting the new functions automatically and renaming things around. Um, how much TypeScript influenced in ECMAScript? So I saw this question being asked in a talk. I think I linked the YouTube video here, and the answer that Anders gave is that the first thing that he mentioned is that C# influenced ECMAScript a lot because of the async await keywords and the whole idea of async await functions. So C# had a really strong influence on that. And TypeScript, he said that their team is always working with the ECMAScript stuff, and they are contributing closely to them. So he thinks they do have some influence. because they kind of work together and they figure out the best things for the community, for JavaScript, and so on. Um, yeah, so my personal opinion, I use TypeScript in everything because I can use things from the future. I can use stage 3 things. I can use the question mark thing. So I can use this. I bet everyone was waiting for this. If you use TypeScript today, you can do this. I'm not sure in which version it was introduced. I have a guess it was 392. But yeah, you can use this. Or you could combine with Babel and use whatever you want. It gives me autocomplete, so I can do window alert and know the parameters, or new date and know the parameters, even the order of the parameters, so it's first year, month, date, etc. Good article. Let's see. Oh yeah, about the operator? Yeah. Yeah, basically you can use question marks instead of checking for if it's defined or not. So you can do this today with TypeScript. Nice article, thanks. Thanks for sharing. So another reason is that you can see errors before you run the code. You avoid typos because it's going to warn you that the variable doesn't exist, whatever. It's easy to refactor. It's easy to scale, so in a really big project, you can rename things across projects. And the documentation is really good. So in the official website, you can find all the documentation, how to use anything you want. So you can learn everything. You should really look at the TypeScript handbook because it's really short and it talks about everything. So you can know everything that you are able to do, and it's really short, so you can learn very fast. So if you want to try it out, you can go to this website called Stack Blitz, and it gives you a lot of options to create a new project. So you can create an Angular project here or a TypeScript project. If I choose a TypeScript project, they give me, so you have Visual Code online, and then you can just code TypeScript here and try things out. If you want to specify a configuration file, I think you have to do it locally. Do you recommend forcing strict no checks? So I personally, I don't like forcing anything. I don't like to use strict. Uh, I don't like to use no implicit any. So if I do no implicit any, it means that um, I don't know how to create an example right now, but it doesn't allow you to use. Oh, maybe I know. Just yeah, no implicit any means that when I don't add types, it forces me to add a type. It doesn't allow me to do any unless I do it explicitly, not implicit. Uh, you asked about strict no checks. So I think strict no checks require you to, if I say foo is a string, I cannot assign foo to undefined. So if I say foo is of type string, it always assumes that foo is going to be a string. It's never going to be undefined or null. So if you use that, you have to specify, in case it's allowed, you have to say, oh, it can be a string or undefined. And now you can assign undefined, but you cannot assign null because null is different from undefined. Um, I I don't like to make anything strict. I am okay with leaving everything really flexible, and I trust developers to type enough that they feel comfortable and it's also useful at the same time. But I I guess I wouldn't mind to work in a strict project, but I guess when I do something, I just prefer to be flexible and not make anything strict. Optional type. Um, yes. So optional. No, optional is not any. So it's something I didn't talk about yet, I guess. But if you have an interface are basically ways for you to define a type of an object. So if I have an interface foo and I have a property bar and boss, I can say they're both strings. If I have a variable foo of type foo, um, that receives var, it gives me an error because it says that boss is not optional. So the optional types is you can put a question mark and then this becomes optional. You can say that bar is optional. And then now it gives me an error because boss is not optional. So if I just pass the required stuff, it allows me to create this object even though I'm not specifying bar. So I guess that would be the optional types. Um, and there's also something called partial. So I can say that this foo is partial foo, and then I can pass just a part of it, even if not everything is optional. So here I don't have anything optional, but because I'm saying this is just partial from foo, then I can specify just some things of it. So there's also this partial thing. Yeah, so in short, I prefer to not be strict, but I wouldn't mind working in a strict project. I like to give people flexibility and I trust they are going to type enough so it's useful. It doesn't have to be super strict. Um, yeah, TypeScript is supported on the major front-end frameworks, so and libraries like so React has this really popular package called create React app, which starts a React project for you with a structure, and then you can just add things on top. And it allows, I guess, Medium broke my code here. Uh, but I can specify a template and I can say TypeScript. Then create React app is going to create a React application for me with TypeScript. So I can do that. Angular has TypeScript by default. And in Node, you can install two packages. So you have to install tsNode, which is going to replace Node when you call the command node index.js. Instead, you call tsNode index.ts, and that's going to run your TypeScript code. And there's also this tsNode dev, which is a wrapper for Node dev. So basically, these both things are just wrappers. So here we have Node, and then we have tsNode, which is the wrapper. Here we have Node dev, which is a package, and then we have tsNode dev. So it's a wrapper for TypeScript on Node dev. And what this does, this dev, it recompiles your application when you change a file. And it's faster than any other thing. So we have other things like supervisor, Nodemon, and other things. But tsNode dev is just faster because it compiles faster. It's smarter. Um, and I guess nowadays every editor has support for TypeScript. VS Code, Atom, Sublime, Vim, eh, like the main, yeah, all editors, have support for TypeScript. They should have. And some stats. So it is the second most loved language in 2020, and this is from Stack Overflow survey from this year. So in this survey, they show here the most loved languages, and TypeScript is second. It's the 7th top language in GitHub. And I found this blog post from our Airbnb. Oh, I guess this answers your previous question, Ed. So Airbnb, they fixed 38% of bugs with types using TypeScript. They prevented 38%. The only other technology that could compare to TypeScript in terms of doing the same thing would be Flow. And yeah, it sucks. So, in my opinion, I don't like it. So I have no interest in learning about it. But if for some reason people want to see an alternative, there's this thing. I don't like it. I'm not interested. And then I also found a lot of bad arguments that people make. So in the beginning of the talk here, I showed that all JavaScript is TypeScript. And then there are a lot of bad arguments that people make. So let's see. The learning curve is too steep. Well, you just need to know JavaScript. And that's it. So there's nothing to learn unless you want to make it a very robust solution. If you just want to use it, there's no curve to learn. So I guess it goes back a little bit to what I was talking, that we prefer things not to be strict, because then anyone, even if they don't know TypeScript, they can just code and they don't really have to learn anything, because nothing is going to be restricting them to do something with TypeScript. It introduces a new standard, so this is completely wrong. TypeScript only follows ECMAScript standards. It doesn't invent its own syntax. It's never going to do that. it kills the dynamic nature of JavaScript. So this is also wrong because you have to type any, so you can convert anything to any, and then you can do anything with anything. So this is also false. Um, it's not going to be around in 5 years. This is kind of an old argument, I guess. It has been around for 8 years and it's getting more and more popular. It's now the second most loved language. I love that you don't need Bubble. Yes, so you don't need Bubble, but did you hear? I'm not sure if you heard before, but actually today with TypeScript you can use TypeScript with Bubble, and it means that you can use Bubble transpiler. So you can use things like in stage 0 with TypeScript. You don't have to wait for it to get on stage 3. You can use stage 0 if you want. Yes, I was like this. Whoa! When I found out a couple of days ago, I think. So basically, you can use anything with TypeScript today, combining with Bubble. Um, Bubble compilation is also faster because it doesn't do type checking. Uh, yeah, but I mean, you're gonna have to build the types with types. So the way it works is you build the types with TypeScript, and then Bubble executes after the types are compiled. In my post there's one example if you want to try. Okay, so more bad arguments. It's not community driven. Well, it's literally open source and one of the most active projects in GitHub. So whatever people that are saying this, they are just blind, I guess. My my screen. Can't talk anymore. Sorry. So my green screen is not actually a green screen. It's a filter, so it's very scuffed. It's a little green screen. I can disable. Yeah, so that's what I'm using for the green screen. Anyway, I'm just gonna keep it for now. Yeah, I think the green screen is better than nothing because I think you can see more. And I don't have an interesting background anyway. Um, yeah, so more bad arguments. All libraries I use are in JavaScript. Wrong. All JavaScript is TypeScript. So you can use any library, even if they don't have types, you can still use in TypeScript, regardless. And they probably have types because the community is crazy. There are over 5,000 folders of types, not including the built-in types for most packages. It's risky because it replaces unit tests. So I talked about this before. Uh, some people make this argument and it's just they don't understand why TypeScript exists. They think types replace tests, which is absolutely wrong. You should never stop writing tests. It's messy. Messy is a large code base that you can't refactor, basically, short. It limits what you can do with JavaScript. I guess I'm repeating here, but that's an argument. Uh, and as I said, it's wrong because you can just cast anything to any, and then you get a variable that it can do anything. It will get stale. It's never going to get stale because it follows ECMAScript. So it's never going to be behind JavaScript. It's always going to be ahead of JavaScript. And now with Bubble, it's going to be ahead of any other thing. And then at the end of my post, I have some resources. So there's this guy called Bassaret. He has a Git book talking about TypeScript, and makes a lot of true points, a lot of good points here. True rumors? I don't know. You tell me. I mean, if you have something to say bad about TypeScript, I'm all ears. Um, but regarding these arguments over here, they are just false. They're like fake news. They don't make sense. It's just not true. I'm learning. Sorry, my voice is. I need to make a break. I'm learning to be a full stack React developer, currently learning to make RESTful APIs in Express. After that, I want to move to React and plan to learn use TypeScript. In your opinion, should I first make some projects using the MERN stack or learn TypeScript before React? Um, I think there are different things. TypeScript and React and Express, they are all different things. I don't know if the order matters. You can learn whatever you want first. Yeah, I don't think the order matters. You can, if you want to learn. So I guess what I would say is maybe it's cool to learn TypeScript first because it's simpler. There are way less things to learn. Or you could just learn like the basics, not worry too much about advanced features. Um, and it's just you can learn TypeScript in some basic, I would say a day. But to learn React, you would need way more time. So it's just faster to get TypeScript all out of the way if you want to learn. Yeah, so in my post here at the end, I have some resources. Like I was saying, this Basarat guy, he's really smart and he has a lot of good content. He even has YouTube videos where he makes like short videos explaining some concepts. Um, so this is a really good place to learn things. And it has even some examples with React here. So I really recommend this guy content. Then there is the TypeScript handbook where you can start here to learn the basics because it's really short instructions on how to do basic things. And they have like this handbook for, I guess, all features that they support, which is not much you can see here, the full list. And you can go get through them very quickly. In the TypeScript website, there's the TypeScript playground. So you can basically code here and see the output on the right side. And you can change the configuration here. So you can strict no checks. So this is the example I showed before. Um, so if I have, it has no checks enabled. If I try to set foot undefined, I get an error. But if I go in the config and disable this thing, I don't get an error anymore. So the playground is really cool to play with the configuration because you can just toggle things on and off, and you can get a full list of the things here. So it's really easy to just mess with the configuration, and you can see the outputs JavaScript on the right side. When do I need to use as for variables? Um, I guess it depends. You can use it in many ways. So one way that I sometimes use is in Angular, you have routes, and I do the routes like this, and then I cast to routes, whatever. So I use as like this, or for database configuration, you have like configs, and then you have develop, and then you can cast, or you could define the type here, type or configs. I don't know. Um, when do you need to use? So I don't know the answer for that. I can't think of examples right now. If you have one example that you can share publicly. Yeah, so you have. So you're saying you do this. Yeah, so you can have it either this way or this way. I use for fixtures when testing to match my models. Yeah, I guess in functional programming you might use more. So I guess if you have fixtures in a object-oriented thing, you're gonna have a new class. So you don't have to do as in the type. If you have a functional programming like we were saying, and then you have like fixtures. Um, wow, you could type like this. I'm not sure. I would have to see specific examples to understand what you're trying to do. Maybe they do talk about casting. Yeah, they talk about casting here. Yeah, so I guess if you have a variable that is the type of any and you want to get the length, you can cast to a string to have auto completion and get the length. Next queries. Yeah, actually that's a good point. So if you get something from the database, um, like if you um, yeah, just ignore that for now. Yeah, so if you get something from the database, Next doesn't know about types. So result here is gonna be any. So you kind of have to cast this to a type if you want, like user array. Yeah, that's a good example. Thanks, Eduardo. So yeah, I guess another example is if you make an API call and then you get a JSON response, you don't know the type of that object. So you have to cast that to something, I guess. Well, in Angular you can do you use the HTTP client and you do a get, and get is generic, so you can say the type here. But maybe for Axios, if you get an URL, you're gonna have to cast the data to something. So you don't need to do as and the type in Angular because the get function accepts a generic type. But like in Axios, you would need to cast the data to something. Data as, yeah, those are good examples. Cool. Um, yeah, and there's a lot of resources here. And I personally use TypeScript for any size of project, even if it's just one file, because it's so easy to set up. I just have to install TypeScript, TS Node, and I have everything. I don't need to do anything else there. And I don't know an argument not to use it. Well, I guess the only argument not to use it is if the project has issues. But then I guess it's a lot of other problems. Then about that, I have a question. How it comes to types in terms of multiple mixed queries. I usually create types for each database table. If you do return like a join, I'm not going to have a class for the join. Um, I think you can combine types. Let me see if I remember correctly. So if I have two types, I can combine them, I think. I hope I'm not wrong. Yeah, so you can combine types. You can combine like um, table 1, table 2, and then I can say join table. Yeah, maybe I can have an extra type which just combine two types, so it doesn't repeat code. So I would have one type for each table, and then a join type that gets properties from. I could do that. But if you're using Nex and you really want types, maybe it would be better to use objection. So objection is a wrapper for Nex that works with types. So in objection, you have one class for each table, but it does support joining things and a lot of things. I think they have some documentation here. Yeah, so if you want to query a person, when you do dot query, this is calling next, and then you do this, and you have types. Here's a join example. Maybe that works. It has been a while since I worked with objections, so I would have to see examples to know that. But yeah, I guess that's it. Um, yeah, I don't have a. I guess I have to look at your code specifically to know how to deal with it. Uh, Maybe we can talk another time. Does anyone have any more questions? Do you have plans for tonight? Do you want a date? uh, I'm free tonight, yeah. Yeah, that's it. Um, any questions? Thanks, Will. Thanks, Ed. Thanks, everyone. If you have any questions, let me know. I can. Um, yeah, just let me know. I guess I'm gonna wait for a bit, and then if there are more questions, I'm gonna. Okay. I guess there are no more questions. So thanks for watching, and I think I'm gonna do another talk, but I forgot the date. I'll be posting on LinkedIn and Twitter. The talk is going to be about. I guess I'm gonna talk about clean code and some of the problems that I see with developers nowadays. For example, that developers use things without knowing how to use things. Like they might use MongoDB just because it's popular, and they don't even know how to use it or why it's used for. So I guess I want to talk about that. If you want to call yourself a developer, a JavaScript developer, make sure you know what you're doing. Make sure you know the functions that exist. Make sure you do maps and not fors. Yeah, that's gonna be my next talk. And I'm gonna talk about clean code. Some things about clean code again. Okay then. Thanks for watching. Until next time.